Okay, title notes today. Is writing equations. For sine and cosine. And when we graphed sine and cosine, we said that there were a couple important things. One was to look at the amplitude of that function. And we said that the amplitude is half the distance between the max and the min. And then we also said the other part is to recognize the period of that function. And the period of the function is the distance, the horizontal distance that it takes to complete one period, right? We also have basic shapes. We have the y equals cosine of x shape that we want to know what that looks like. That starts at a max and ends at a max, something like that. We have the y equals sine shape, which is starts at 0, 0, and goes to its max, goes back down to its min, and back to kind of the equilibrium or 0, 0. And then the other two shapes would be the inverted shapes of these. So if you have a negative sign in front of the cosine, you start at the min, end at the min. And for the sine, you start at 0, 0 again, but you go to its min first, and then its max. Okay, so those are the only four general shapes you'll see when 2 for cosine, 2 for sine, depending if it's positive or negative. Okay, so you look for those shapes when you're writing equations, and based on the shape, that tells you what kind of equation you're going to work with. But then you also want to look for the amplitude and the period of that function, and those together will help you form your equation. Let's look at an example. Write the equation of the following graph. Okay, so we have the shape of the graph. We have some information on the y-axis, which is going to help us get to the amplitude of the function, and we have a little bit of information on the x-axis. It's going to help us get to the period of that function. Okay, and remember, well, what shape is this? Sine. Okay, so we get the general form would be y equals a times the sine of b times x. So we know the shape, and now I need to find a and b. Okay, to find a, that's the easier one. That's deals with the amplitude. And in this case, we just look at the y-axis, and right there, that's going to give us a. Okay, so now we know it's y equals 7 times the sine of b times x. Now, b is related to the period of the function, and the period of the function is 2 pi divided by b, right? And so if we can find the period of this function, the period of the function is actually whatever x value is right here, right? We can find that x value, we found the period of the function. And remember, when we're looking at the x-axis, the critical points are at the maximum, the x-intercept, the minimum, and the max, min, and x-intercepts. and it divvies this function into 4 equal parts, right? So the distance here is the same as this distance, same as this distance, and so on. And so if we know this full distance is 2 pi over 5, we can go back and find out, well, what's one of those segments? If 3 of the segments equals 2 pi over 5, we can find one of them by dividing it by 3. And so I'm going to find 1/3 of 2 pi over 5. Which in this case would be 2 pi over 15. Is that the period of the function? No, that's this value right here, 2 pi over 15. And then I can count by 2 pi over 15. So 2 pi over 15, this is 4 pi over 15. This is 6 pi over 15, which is the same thing as 2 pi over 5. And then count one more and I get 8 pi over 15. So if you can find this value right here, that's what you count by. That's kind of our increment that we can count by to find anything on the x-axis that we want. Okay, so I had to work backwards first by dividing by 3, and then I counted by 2 pi over 15. Now I know my period is 8 pi over 15. Once you got the period, you can plug it in this equation. 8 pi over 15 is the period, and that's equal to 2 pi over b, and now I could solve for b. It's a proportion, so we can cross multiply and multiply 8 pi times b, so that equals to 15 times 2 pi. And then I want b by itself, so I'm going to divide both sides by 8 pi. And I get b is 30 pi over 8 pi. And then we reduce that. Divide by pi, divide the 30 and 8 by 2, you get 15 over 4. So now we found b, and we can write our full equation, which is y equals 7 times the sine of 15 over 4x. That's the equation of that graph. Okay, so it's pretty easy to see the shape and decide, okay, that's the sine graph. It's pretty easy to come up with A, which is the amplitude. It's a little bit of work to come up with that B, right? Here, our second example, again, I want you to find the equation of this following graph. Here's a piece of the graph, and I'm going to tell you that, give you some numbers on the y-axis and the x-axis. All right, so there we have it. So we have to ask ourselves 3 questions. First of all, which shape does this belong to? Is this a sine, negative sine, cosine, or negative cosine? We got 15, negative 15 on the y-axis, and negative 3 and 3 on the x-axis. So you guys think it's positive sine? It's actually the negative sign. Because this is a little tricky because it looks like the shape of the positive sign, but where you have to look right now is you have to start at 0, 0. This is the part right here. And if we continued that, that's the shape we would have. So this is the negative sign now. Okay? Don't be fooled by the left side. Okay? So it's a negative sign because from 0, 0, it's dropping down to its minimum. And what's the amplitude? 15. So I kind of grabbed those two, do those first 2 steps together. So we know this is going to be y equals negative 15 sine of bx. So the majority of the work now is just going to be find out what b is. This one's not as hard. What's the period of this function? 6, right? Because that 3 is only halfway through the pattern, right? Starts at 0. Only look at what I highlighted. I've only gone halfway through the pattern at 3 there. And so I need to go another half to get that full period. So the full period of that horizontal length to complete that pattern is 6. And so the period of a function is 2 pi over b. And we know the period is 6. So 6 is 2 pi over b. And we can make that a fraction 6 over 1 and cross multiply. So 6 times b is 2 pi. And divide by 6. And we reduce that fraction, you get pi over 3 for b. So our equation should be y equals negative 15 sine of pi over 3 x. Okay, question on that one? All right. So next one, example 3. Write the equation of a cosine function with a minimum value at 0, negative pi, and let's see, and its first maximum at 3 pi, comma pi. Right? So sometimes you're given a description of the graph in words. You don't have the picture. So the first thing you need to start with is a picture. Okay, so try to draw what's given to you. Try to label the x-axis and the y-axis the best you can, and then go to the equation. So you know it's a cosine function. When you sketch this graph, plot the points. So 0, negative pi, that would be right here. And that's the minimum. So on the x-axis, we're starting at the minimum. So this is the cosine flipped upside down. So we know it looks like this. Here's one period of our cosine function. Its first maximum, right here, that point, is 3 pi, which means the x value is 3 pi here. And the y value, the height, is at pi. And there's your picture that you want. Okay. So what's our amplitude? Pi. And it's a negative cosine function, so we should have y equals negative pi times the cosine of bx. We've got to figure out what b is now. And b comes from the period of the function. The period of any function is 2 pi divided by b. And what's the period of this function? The 3 pi is only halfway through the period. The full period is right here at 6 pi. It's the full pattern. Because half of it is 3 pi, so I go 3 pi more. This is the halfway mark, right? And so we end up with 6 pi is equal to 2 pi over b. And we can make that a fraction equal to a fraction, so we cross multiply and get 6 pi times b is equal to 2 pi. Divide by 6 pi, and you get 2 pi divided by 6 pi, which is 1 over 3. The pi's cancel out. Okay, 1 over 3. And so your equation should be y equals negative pi times the cosine of 1/3 x. Okay, example 4, write the equation of a cosine function with a maximum at 0, 5 and its first x-intercept to the right of that maximum at 5/3, 0. Start with a picture and then develop the equation. So this is a picture you should get. So is this a positive cosine function or negative cosine function? So we got y equals 5 cosine of bx. We need the period of this function. What's the period of this function? We need to count by 5/3, right? This would be 10/3 here. This would be 15/3. This would be 20 over 3. So 20 over 3 is the period. And that's equal to 2 pi over b. So we cross multiply to get 20b is 6 pi. We divide by 20, we get 6 pi divided by 20 is equal to b. We can reduce that to 3 pi over 10. So our equation for this function is y equals 5 times the cosine of 3 pi over 10 x.